And I'm going to ask each one of you to go over use the commands with the data set I'm going to use. That data set is already on Excel, on Word, not Word, sorry. It's already on Blackboard, but it's an Excel file that I uploaded. I used it before, a long time ago I called it the new macro data, but I'll remind you again where it is. It's on Blackboard under class practice. I'll give you the details in a few minutes, okay? And so I would ask each of you to practice with it and then bring your questions to class on Thursday, because after that, I'm going to give you your next homework, but your next homework will use exactly the commands I'm going to practice with you tonight. But I'm going to ask you to use those commands to work on your stock, whatever stock. Remember the first homework you did, you already downloaded the stock. So I'm going to ask you to use that stock and use my commands to do the homework. So this will be a relatively easy homework for everybody. But I'm going to begin tonight to show you the things I discussed last week, how we use the command. Can we pick a new one? Yeah, you can pick a new one, Nikhil, as long as it's, yeah, you can pick a new one, no sweat. All right? Okay. Can I do a coin, like Bitcoin? Yeah, okay, I'll answer that question later, okay? But it depends on the kind of coin from crypto market, okay? Hey, why not, why not, why not? I want to see the result too, okay. All right, can everybody hear me okay tonight? I seem to be losing my voice. Can you hear me okay? Somebody tell me yes or no.
Yes, Professor, we can
Yes,
hear you very well.
Okay, awesome, 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 okay. From time to time, if you guys don't mind, I'll pop this. It's a throat thing, okay? If it gets very bad, I'll pop it. Yeah, things are okay, not too bad. And let me just say this. I'm going to take my COVID-19 shot either tomorrow afternoon or early Thursday. So I think if I take it early Thursday, by class time, I won't feel bad. But if I take it tomorrow, which is a little likely, I'm waiting for the appointment to confirm. If I take it tomorrow, Wednesday, then maybe I hear within 24 hours, it can knock you down or not, all right? So if it knocks me down sometime on Thursday afternoon, I will send you an email, I'll send you homework, or I'll send you something to read. But if I'm not able to come to class, then I'll let you know on Thursday afternoon, okay? But I'm definitely planning to come to class. And somebody says take performance enhancers for his throat. Okay. I will.
I heard, Joe, you should drink a lot of. I heard you should drink a lot of water before. Also, I heard that drink a lot of water that day.
Yes. So somebody says drink a lot of water. Other people say keep just yeah. I've been doing vitamins for a year now, but I think I'll feel good. Tea is good. I'll feel good, but this is just on the outside chance. Okay. Even if I cannot teach, I may come here, and rather than talk for the whole hour, I will do kind of an hour session again on something else, okay? But I tend not to be sick. So, but just on the outside chance, I just want to let you know, okay? But I'll communicate with you. Okay, so what I want to do tonight, let me just get going, okay? And then, so your next homework, I will probably make it available to you on Friday evening. Most probably, okay? I wanted to say Thursday, but I don't know how I'll feel. So I don't want to promise for Thursday. So Friday evening, sometime before midnight, I'll post it, and then you'll have 1 week to do it. But honestly, I really, because you guys, you did so well on my midterm, many of you, and the second homework, most of you did excellently well. So I think you are we're all beginning to get the hang of it. So what I'm going to do tonight is all the commands you are going to need for the homework. And then I am going to use the GDP data. Okay, it's already on Blackboard for you. I posted it like 2 months ago, but then I'll remind you, if you go, you get it, okay? And then I'm asking you to work on it between now and Thursday, so that if you have any questions at all on using that database, you can ask me or text me, or not text me, email me or whatever. But again, I'm planning 98% to be in class on Thursday. Even if I cannot teach, then I think I can be able to answer our questions, okay? All right. So the next homework you are going to do, if you guys work with me today with this commands, and you work and you practice it, it's really simple. Then if I give you the homework on Friday, by midday Saturday, you should be done, okay? But the difference is what I'll do tonight is I'll run each line, and if we get a result, I'll try to explain the result to you, okay? So I want you to explain your own result using your own stock, using your words, but the way I'm going to explain it tonight, okay? So that's all you need to do. So please pay attention. And the commands I'm going to use tonight, after tonight, I'm going to post everything on Blackboard for you, all right? I'll post the Word file. You can just copy the Word file and put it on R, which is what I did. All right, so let's go. Does anybody have any last minute question at all? Some of you, I sent you emails during the week. I sent you emails early yesterday or 2 days ago. Yes, and I said, if you can, see me after class tonight, so that I spend a few minutes with you going over your midterm exam results and all that, okay? I want to see everybody one-on-one. Even those of you that did well, I will. So what I'm doing is I'm randomly picking. Initially, I said, I want those of you who were not happy with your performance. But I thought again about it, and I said, instead of posting time, what I'm going to do is I'm going to be sending you emails. So if I ask you, for example, Danny, if I ask you to meet me like Wednesday, but you cannot, just email me back, say, Professor, I cannot, can we reschedule? So I can reschedule with you, but then I can find somebody else to take your place, okay? So before middle of next week, I should be done seeing everybody in class.
Professor,
about the midterm.
If you previously spoke.
Yeah. You tonight, I'll see you tonight, okay?
Okay.
Yeah, so those people who I already scheduled from last week, I'm seeing them tonight, definitely, okay? There's a lady who wanted to see me last week, and I told her I will post the time, but since I changed my mind, I don't remember who it is. So whoever you are, just remind me and I'll see you tonight, okay? And if you can't see me tonight, then I'll see you either Wednesday or Thursday. All right. So Joseph Bishopan, I'll see you tonight, okay? Don't worry about it.
Thank you, Professor. Thank you.
Absolutely. All right. So I am going to begin the program. Again, you guys, you remember it's me. So keep your eyes on me, all right? And the commands I'm going to use, make sure you understand them and ask me a question if you don't. All right, so I'm going to, let's see, I'm going to do this. All right, I'll bring up the hour session. I always like my hour sessions to be informal so that you guys will see that it's not really a big deal, okay? Let's see, okay. Does everybody see this, our studio screen? Everybody see this, right?
Professor, can you please start recording?
Thank you. Thank you very much. Okay. I knew I was forgetting something.
This meeting is being recorded.
Okay. Oh my God. All right. Thank you for reminding me to record. Okay. So here goes the hour session. Fingers crossed. And if I make mistakes, I'll just do it again. Okay. So please bear with me. All right. So what am I going to do? So the first thing I want to do, the first 3 lines, we already did them in the past. So what I'm going to do is I'm going to set my working directory to my, this is me, this is my desktop, and I'm going to look at this folder, okay? And then in that folder, there is this file, macrodata.csv. Remember, again, in case you have forgotten, if you have an Excel file, .xls, XLSX, the Excel extension, it's usually a problem to if you bring it like that into R and you do complicated calculations, it will be a problem. So we recommend you change it to CSV. So .csv, look at the extension here, .csv. So so how do you do that? I'm sure I've showed it to you in class, but I'll be happy to show it again, okay, tonight. All right, so the first thing I want to do is I want to set the working directory. So I set the directory and I run it, okay? Everybody knows how to do this by now, but stop me if you have a question. Again, these commands I'm going to make available to all of you on Blackboard. Okay, so look, so I got a good result here. I set the directory. All right. Now, what I'd like for you to pay attention to is, I was looking at the textbook a few days ago, and it dawned on me that, because for me, usually when I want to do R sessions, again, I don't know about you, but when I want to do R sessions for my own personal work, my God, you guys need to see, I will install like anywhere from 10 to 15 packages. And then I'll library all of them, because I really don't know which one does what. Of course I know, I can take time to check, but sometimes I don't even bother. I know what I want to do. I know that Zoo will do it. I know that QuantMod will do it. I know that Tst Series will do it. I know, so everything I know will do what the many
Hey, what's your
many
favorite
tasks I
anime?
want to do. I'm just lazy. Okay, I just install all of them at the beginning, library all
What
of them at the
about
beginning,
Hero
so
Academy?
that, and then I begin to do my work. So I don't have to worry
My
about,
friend's
do
asking
I
me.
go get this package? I just install everything at the beginning.
School friend.
But tonight, I want to see how
What your
far we
favorite
can
anime
go
is?
without installing a package, because that means everything I'm going to do now, I'm not going to install a package until I can go no further. So that tells me that many things we're going to do tonight, let us see how much of the tasks can be done using the core, C-O-R-E, using the core programs in R. Because when you install R, like all of you know, when you install R, you are installing many programs with it. Just like when you buy Excel for the first time and install it on your program, it comes with many things. But then if you need to do regression, then you need to activate data analysis. It's there, but you need to activate it. Remember, we did that in class. Okay. So I want to see how far we can go tonight using only the core programs that comes with our installation, the core packages. All right. Okay, I hope everybody understands what I'm saying, but if you don't, when we get there and we run into problem, then, okay, so I'm going to run the second line. Okay, so what does this second line do for me? Can anyone tell me? The first line, I tell R to go, blah, 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 to go to this folder, okay? And R goes there. That's the first result. And then the second line, I tell R to go to that same folder, but look into that folder and please bring up this file. I'm sorry, the name of the file is just too long. So when you download it from Blackboard, you can change the name to something simpler, all right? So the file name is r_practice_new macrodata.csv. All right, it's already in Blackboard. I put it on Blackboard on, Tuesday, March 2nd. So if you go to your course documents, you will see class practice data for Tuesday, March 2nd, 2021. It's already there. But at the end of this, I'll type, just go there and look for it. I'll give you the details how to find it. But I checked before class is there. All right. So what have I done? I have brought in the data. I am going to show you the data very soon, but I don't want to show you everything. Not now. So what have I done? This third line, can anybody tell me what this third line is doing? This third line. You all know because many of you have done it for your homework. This line 3. What am I doing in line 3? TS.
Converting the data to time series.
Exactly. So I'm telling R that this data, I want you to think of this data as a time series. And I love this class because many of you use other fancy commands. I see other fancy commands that many of you use. But me, I just say TS. Okay, so sorry. So this second line brings in the file, and there's data in the file I'm going to show you in a second. But then R doesn't know whether it's time series, whether it's cross-sectional, whether it's panel. It doesn't know what type of data it is. So I'm telling R, treat this as I want you to treat this as a time series. So this TS says data, whatever you have in data, okay, from beginning with frequency 4, meaning it's quarterly, treat this as a time series and put it in data 1, okay? So that's what I'm doing. So I'm going to do that now. And I hope it works. Okay, so it works. So it has accepted it. Then let us look. Somebody has a. So let us look at the data now. Okay, so look at the data. This is the same data you have already. Many of you already have it, and it's on. Okay, so here it is. It's already on Blackboard, like I said. And if any of you can go to Blackboard and get it and post it for everybody. William, you already did it.
One step ahead of you.
Huh?
Yeah, I was one step ahead of you.
Yeah, if you're 5 steps ahead of me. I was just going to say, if any of you can be kind enough to go and get it and post it on chat.
Extra credit.
Extra credits, I buy you coffee when I see you at Baruch, okay? Thank you so much, William. All right, I appreciate that. All right, so this is the stuff, okay? This is the data that you see. See, it begins 1970 quarter 1. Quarter 1 is 1970 is GDP, and so on and so forth. So you see what R has done. You see this column here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. R just introduced that because I said treat this as time series. So he said time 1970, which is Q1, it makes it 1. 1970 Q2, it makes it 2. So this is the result of me saying TS, time series, on line 3 here, okay? All right. Please, you guys, just stop me if you have questions. Otherwise, let me just keep going. Is that okay? All right, so
Wait, Professor.
I do start.
If you have
the beginning of the data, that's what this start says.
Professor, I have a question.
Yes, sir.
If you have it as frequency 4, wouldn't that make it yearly or annually?
No, frequency 4 means 4 times a year.
But then the data is done quarterly.
Yes, so that means because there are 4 quarters in a year. Look, 1970, are you looking at the results below here? 1970 Q1, 1970 Q2. So Q1, Q2, Q3, Q4 make up 1970.
Okay, so
you see 4 quarters.
Yeah, I thought that was the data. My bad.
Okay, so if it was annual, then for 1970, I'll have only 1 observation, yes? If this was annual frequency, right? And then the frequency would be equal to 1 here. Yes, Andrew?
Okay.
Yes. So the homework you've been doing, what have you been using? Monthly, right?
Yes.
Okay, if you use my command here, then you make it frequency 12. But again, many of you have your own commands. That's okay. But if you want to use my command here, TS parentheses data start is 1970, frequency 12. That's for monthly data, okay? All right. Okay, so I want to do the start of the data. It says, when does it begin? Here at the bottom, it says it begins 1970 with data 1. So the first quarter is 1. Are you looking at my cursor here below? Do you guys see my cursor?
Yep.
Okay. Okay, so that's the start. It says it begins in quarter 1 of 1970. All right. So head. Does anybody remember what the command head does for R?
Shows the first.
Yes, I think it's either the first, yes, either the first 5 or the first 6. I don't remember, okay? But we'll find out very soon. So I do that, okay? So it shows the first 6. 1, 2, 3, 4, 5, 6. So it shows the first 6 of the database. All right? Now, for the exercise I'm doing tonight, I want to use GDP, okay? I want to use GDP. And let me back up here. See, this thing has several columns. It has GDP, PDI, personal disposable income, PCE, I believe is personal consumption expenditure. It has profit, it has dividends. So these are all macro variables I downloaded somewhere, from somewhere. So the command on line 7 says, from this data 1 that contains everything, give me all the rows. Remember, so blank comma, meaning take all the rows, but I want go to the column called GDP and take all the rows, ROWS. So here, if I put a number here, 5, it will go to column GDP and get me only the number in row 5 for GDP. But I want every row of GDP. So if I run this, all right, if I run this, so I run this here, it tells me it's okay. Okay, it worked. So let me, you know what? So let me print R now. Let me type R. Sorry, I'm going to add to this. So let me just type Y. Show me Y, because I told R to extract all the quarters for GDP and put it in Y, in the address called Y. So let us see what Y looks like now. Okay. What happened? Yeah, it gave me. I hope it didn't give me everything. Okay. So it gave me Y, it gave me GDP, but see, it just broke it down into quarters. Quarter 1, quarter 2, quarter 3, quarter 4 for GDP. So in 1970, GDP for quarter 1 is this, quarter 2, quarter 3, quarter 4. In 1971, quarter 1, quarter 2, quarter. So it gives me only GDP, okay, quarter by quarter for all the years. Okay, so far so good? Somebody is chatting with me. Yeah, that's cool how it's separated. Yeah, I'm sure, again, you can play with this. You can make it do only rows all the way down, but that's not cool. Okay, Andrew, you said it's cool the way, yeah. I like the way it separates it into quarter by quarter. And I think that's great. All right, so, okay. So let me plot Y. So you plot GDP. I'm going to plot the GDP number. Wait, what happened? Oh, no. Did I mess up? Okay. So I think I chose the wrong thing. So let me plot Y. All right. If you look at the bottom right-hand corner, you will see Y. I just want to wait here and let somebody tell me that you see this graph. Do you see the graph on the bottom right-hand corner? Okay, so for homework, usually I ask you describe. What am I looking for? I'm looking for, to tell me, is there a trend? So does this look like there's a trend? Yes, there's a trend. There's an upward positive trend. It's going up. Sometimes it's going down, negative trend. So the first thing you want to know, so when I say describe, as much as possible, try to describe to tell me how much of the components of a time series are there. Does anybody remember the 4 components of a time series? Can anybody remind me?
Mean, variance, skewness.
No, those are the moments.
Oh, moments. Oh, my
Yes.
bad.
Yes, there's a trend, there's a cycle, there's a season, and there's irregular, right? Remember that?
Right, yes.
Yeah, okay. So the components are trend. I know you know what I'm talking about. Don't worry about it. So the components are trend, cycle, seasonal, and irregular. So TCSI. So when I ask you to describe, many of you already are doing this correctly. When I ask you to describe, I want you to tell me what you see in your graph of your data. So here, so what do you see? Of course, I see a trend here. It's going from left to right, up. I see an upward trend, positive trend, going up over time. Then I also see something like, look, it goes from here, it goes here, it goes here, it goes here. So I see some little bit of cycle. Again, you can debate that, but it's not very well pronounced. Between 1970 and 1985, I kind of see this go up and down, a little bit of cycle, a little bit here, okay, and cycle a little bit. Again, you can argue that this is a weak cycle or the cycle is not very pronounced, okay? Then you can say seasonality too, because you can say, look, between 1975, even if you look from 1970, there are some little squiggles. There are some little squiggles. So that could be seasonal, maybe quarterly seasonal or annual seasonal. If this company is Coca-Cola, if your company is Macy's, for example, then every December the sales will spike up, and then January it's like nothing, no sales, and then December again it spikes up. So those are seasonal stuff. Cycle is like business cycle. Every 5 or 10 years we have cycles. So those are more long term. Okay, so that's what I'm looking for when I ask you what describe this graph. Okay, good. All right, so let me move on. All right, the next command, I don't need to do it. We already did it. Okay. This command, the difference data, I put it there because you see, usually for your companies, I ask you to plot the prices and you see trend. Then I ask you to plot the returns. Okay, I ask you to plot the returns. So here, I'm not doing returns to GDP because no, it's not, it's stock. Here, I want to do a differencing. Differencing meaning Q2 minus Q1, Q3 minus Q2, Q4 minus Q3. I am not dividing by the previous. I just want the difference. I don't want percentage. I don't want returns or percentage changes. Okay. All right. So I'll do the. Let me just do the difference here. I think I already calculated it by error earlier on. So let me do the difference. So this can proxy for our return. Okay, it worked. And then let me plot dy. Okay, let me plot it because I want to show you. So I will put it here. Plot parentheses d dot y. Okay, so if you notice here, look at the command here, diff. This is I didn't make it up. This is the command R recognizes. Diffy, meaning difference the observations of y. So Q2 minus Q1, Q3 minus Q2, quarter 4 minus quarter 3, all the way down to the last quarter. So it does it, and it puts it, for me, it put it in D dot Y. So D dot Y reminds me that this is a difference Y, okay? So let me plot it and see. So that can proxy for return. Let's see. Okay. So look, you see? Everybody sees this graph. So assuming that this is like the return, what do you see here? Well, it hovers around mean 0. So there's no upward trend. So anytime you difference data or you calculate the returns, what are you doing? You are removing the trend, okay? Essentially what we say is you are detrending, D-E-T-R-E-N-D. You are detrending the data. You are removing the trend. Remember prices, it was heading up. But by taking the successive differences, you are removing the trend. So now what do we have? We have cycles. Look at, yes, one cycle here, one cycle here, one cycle here, one. And then we have seasonal, seasonal from year to year or from quarter to quarter. And then we have irregular components. Okay, we have some parts we cannot predict. Okay, but the bottom line is, because this has been detrended, it's hovering around mean 0. So it goes up around 0, above 0, comes down, goes up, comes down, goes up, comes down, comes down. Okay. The next, what many of you always forget to tell me, do you see volatility cluster here? Does anybody see volatility cluster?
Yeah, I think from right around 1985,
Okay.
where your cursor is.
So it's a weak one, but volatility cluster sometimes is very sharp. You see, big volatility and then small volatility and then big volatility and then small. I showed you this in class some time ago, okay? So for this graph, you can see there's mild volatility clustering around 1980, 1985. So the clustering can be, but for some data, for the homework you will do using your own stock, you will see the volatility cluster begins from beginning of your data to the end. And that is what in chapter 4, we are going to try to model using Arch and Gach models, okay? All right. Any questions so far? All right, so I'll speed up when I pass this whole. So,
Professor?
yes, sir.
So the difference of y, is it actually, when we find returns, don't we also divide by the previous number?
Exactly, but in this case, this is like the numerator of your return, but you are not dividing.
Right.
Okay.
Got it.
Yes. So yeah, you're correct. Okay. Okay, so this is descriptive statistics. I already did that. So I already plotted y. You saw that I plotted d dot y. Okay, y has a trend. D dot y, the difference, y doesn't have a trend. Let's do summary, okay? Summary will give us some statistics, I'm thinking. All right. So summary y, it tells us, look, at the bottom left-hand corner, minimum, first quarter number, median, mean, third quarter, max. So it gives you these basic statistics. Remember, if you want more, then you can install FBasic or FBasics, the one we used earlier from chapter 2. Okay? So if you want, no, from chapter 1 of your book. FBasics, you remember the homework I gave you, the first one where you did the Jacques Beira, you did the moments. We use FBasics for that, and that will give you humongous number of statistics. But here, I just want brief summary. So it gives me mean, minimum, maximum, mean, first quarter. This first QU is not first quarter, I'm sorry, it's first quartile. So it's the 25th percentile. The median is the 50th percentile. The third quartile is the 75th percentile, okay? All right. And then D, and then summary of D dot Y is, let's see. So again, it tells me minimum, maximum, it tells me all those statistics. Okay. So let's do the ACF quickly. So we do the ACF for Y. This database drives me crazy because GDP is just so nasty. So take a look at what the ACF looks like, everybody. See the ACF. What do you think? Everything has broken through the confidence band, the dashed line. But you see, it is coming down gradually, yes? So what do you suspect? What kind of model is this? You can suspect an autoregressive model is within GDP. But that doesn't mean it is entirely only an autoregressive model. It could be ARMA. But what I know is that because this is declining exponentially slowly, that it has an autoregressive component. It has an AR component. All right. Let's look at the PACF, the partial autocorrelation function. Aha. What do you think?
It's not AR.
Yeah.
Well, it looks like AR, but AR1. Okay. Again, it says lag here. So this should really be, I don't know why this, the horizontal axis is compressed like this. But I would say, let us look, because, well, this is PACF. It goes, I don't know how to interpret this, but if you look at the lags themselves, you can say it's not really a pure AR model. All right. But in my mind, let me assume that the horizontal axis for lags, something wrong with it. Because here, there's, these are quarters. Oh, I see, these are quarters. All right, these are quarters. So Q1, Q2, Q3, Q4 is here. Q1, Q2, Q3, okay, okay. So these are quarters. So I'll say that in the first lag here, first quarter lag here, that we have this sticking out. So if I, again, this GDP data, me and my colleagues, we work on it. It drives us crazy because it's very complicated to track. But let us make a note that AR1 looks good for this. But I can tell you that it doesn't, and I'll tell you the reason why later. Okay, so let's look at ACF for difference Y.
Professor, can I ask a quick question about
Yes.
PACF?
When it's PACF, yes.
Yeah, when it's this, no, sorry, about the ACF,
You want me to plot it again?
Sure.
Okay. So let me plot it again. Okay, here you go.
So when it's when we notice smoothly declining bars here, should we suspect that it's AR1 process?
No, it's an AR.
Okay.
And let me caution you. It might be an ARMA. It can have AR and MA components, but we don't know that for now. You and I have not studied moving averages. But yeah, what I know is that even if it's an ARMA or ARIMA, whatever, there's an AR component here because Joseph is declining, exponentially.
I see that. Okay, thank you.
Okay, but because I have done some research using this, I suspect, because this is dying very, very slowly. The AR models we have seen so far, they kind of die quickly, right? In the past. This is declining so slowly that it might just go forever there. Okay, maybe not forever, but many, many lags. So this,
right,
like it's an is a fractionally integrated ARIMA. Okay, but we haven't done that in class.
Right.
But for the purposes of this class, because it's declining exponentially, we can say whatever this model is, it has an AR component. That's the safe way to regard it, okay?
And so according to the PACF that we just observed,
yes,
we
can say AR1.
Okay, all right.
Okay, yes.
Yep.
For the purpose of this class, if you say AR1, that's good enough because that's what the PACF is showing you. Okay.
Yep. Professor, can we look at more lags on the PACF?
Yes, you can look at more lags. But I don't want to do that because you can do that in your spare time, okay?
Okay, no problem.
All right. So for DY, let me just do the ACF and let's see if we can figure out what the ACF is. I have a few. Okay. Now, Joseph and Andrew, look at this. Look, you see this one just dies down quickly. You see that? Bingo, it just dies. Okay. And then, I mean, this is totally messed up. And then it breaks open here, breaks open here, breaks open here. So for the ACF of the difference data, I can say it's a little bit of AR with positive coefficient, but also with negative coefficient, because from here, you see, is declining this way. There's positive coefficient on the top, there's negative coefficient on the bottom. Okay, again, this is very tricky to determine, but you can say safely what you observe. Maybe it's an ARIMA, but we don't know. But now I can say at least I see some AR component with positive coefficient and some AR component with negative coefficient below here. All right, not precise, but sorry. All right, PACF quickly. Look, this is screwed up. So if you want to do an AR, then it's an AR1 is good, AR8, AR12. So again, we are going to we can use the AIC later on to check which model is best. Is it AR1 or AR2, or I'm sorry, is it AR1 for quarter, or AR8 for the 8th quarter, or AR12, because this 3 means the 12th lag for the quarters, right? So again, my suggestion is when you are doing model building, just put AR1 model, AR1 and AR8, then AR1, 8, and 12. And then estimate all of them, and then choose the one with the smallest AIC. Do you guys understand what I'm talking about? Yes?
Yes.
Okay. So sometimes you get confusing results like this. Okay, I'm not sweating it. I'm not saying, oh, pulling out the hair I don't have, pulling it out that, oh, I thought it was AR1, but no. All right. I say fine. One model, I'll call it AR1. The second model, AR1 and AR8. The third model, AR1, AR8, AR12. So I have 3 equations and so on, okay? And then I'll estimate them, and I'll show you how to estimate them in a few minutes. And then look at the one with the smallest AIC or the smallest BIC, but I'm going to use AIC today. So that's a quick and dirty way of doing this. All right, so let's move on. Okay, so here, if you guys look on the top left-hand corner, this is from page, the set of commands on page 63 of your textbook. I extracted the commands that are useful from there, okay? So every line here is from your textbook. I believe it's page 63, okay? So it measures I said here, computing AIC from chapter 2, page 63 of your textbook. So your textbook measures, and actually that example is for GDP. in your textbook, but not the same GDP I'm using here. It's not the same data, but it uses GDP data. I'm using GDP data too. So here it says, let's do AR. Let us do AR. Let's estimate AR for GDP. Remember, GDP is my Y. And let us use a method called maximum likelihood estimation method, MLE. Don't worry about the details. This is just one method that this program uses. And the result, let's put it in MM1. And then when it computes this line 33, it's like you do OLS on Excel. When you do OLS on Excel, Excel gives you so many results, okay? Excel gives you R squared, adjusted R squared. It gives you T statistic. It gives you standard error. It gives you a million things. And then you can pick and choose which one you show. The good thing about R, unlike Excel, Excel will just bounce everything out on that page for you, and it clutters your page. But R, you give it the command, it runs it, and then whatever result you want, you go get it, okay? So let me run this. So I run this. So it tells me it has run. So it has estimated an autoregressive model. And then I want to say, find me the order. Okay, find me the order, meaning, what lag do you think is best using this equation that is used to run an autoregressive? Which lag length, which lag order is the best according to this equation? So that's what I'm going to ask it now. Okay, so it says MM1 dollar order. So when you put dollar, it tells you that the result you want is the order of the autoregressive. If I put dollar coefficient, it will get me coefficient, okay? So just put dollar and whatever you need. So I'm going to run this here. So it tells me the order is 3. So look at the bottom left-hand corner here, at the bottom where my cursor is moving. So it tells me that when you run this AR model using maximum likelihood estimation, that it found that the best model is an AR3 at lag 3, okay? All right, so let's put names. Okay, so I put names here, meaning these are all the things. When it ran this MM1 on line 34 on the top left-hand corner here, all the results, the name of the results are this: order, number of observations, AR, order max, call, and so on and so forth. And then it has residual here, it has mean, it has predicted variance, it has partial ACF, it has, look, AIC, it has this AIC, AIC information criterion. You see that? All right. So let us print this. Let us print the AIC. Okay, look, before I run it, it says print MM1, but print only the AIC. So now we're going to print the AIC for this autoregressive, and then we're going to see where the AIC is minimum. It already told us that it's minimum at 3, order 3. So let us look at the numbers themselves, okay? So I'm going to run it now. Again, this is directly from your textbook on page 63. So I'm running line 38 now. Okay, so look, on line 38. Now, so these are the AIC. So tell me, which is the minimum AIC here? Do you see it at the bottom?
Lag 3. For
lag 3, exactly. The minimum is 0.00. Unlike when we did AIC, when we ran AIC on the PACF last week in the textbook on page 62, you remember all the AIC numbers were negative. Remember that? So we chose the largest negative. Yes, Roxolana, you have your hand raised.
Yeah, I'm kind of confused because before you said it wouldn't be called an AR3 model, it would be called like AR12. So like, how would we know whether we call it like if we're doing it based on quarters or the lags?
Here, remember here we're dealing with quarters.
So it wouldn't be AR3, would it be AR12?
That's a good question. You're saying, is this quarter or is this years? Is that what you're saying?
No, it's like whenever we have to say which one is the best model, you said it's AR3. So does that mean it's? I'm kind of confused because before you said at lag 3, it's actually AR12, right?
Okay, all right. So here, let's go back to the bottom right-hand side here. So here it says lag, right? Lag 1, lag 2, lag 3. That's what you mean, right?
Yes.
And then each of these observations, 1, 2, 3, 4, 5, 6, it's in quarters, I said, right?
Yep.
So you're saying this 0.0, is it quarter 3 or is it quarter 12? That's what you're saying, right?
Yeah.
Okay. Let me not answer that. We shall see.
Okay.
Just wait. We shall see, because I don't want to give you the wrong answer.
Okay,
all right?
Thank you.
Okay. Let's just see. This is what your textbook did. I wouldn't do it this way, but that's what your textbook did. All right. So let's go on. I think somewhere and your textbook later went and plotted it. So we shall plot it and we shall see. Okay. Below. So let's go here. So it says here, I already ran names, I already ran this. Okay, for plotting below, AIC, let's put everything under AIC. So we want to plot this. So I'm setting us up for plotting. Okay, so it worked. So I put all these numbers under AIC. And let's look at the length for AIC. Okay, so it says the length, we have 13 here, because remember we begin with 0 here, 1 plus 12, that's 13. So that confirms what we're seeing with our eyes. Then let us plot it. So we're going to plot the line. So it says plot all the lags from 0 to 12, and AIC type H, X label, Y label, that's the usual thing. Okay, look at it. I plotted it here. We plotted it here. So this is 0, 1, 2, 3, 4. So I guess these are in quarters, all right? So let me put the lines. So this joins the lines. Hold on, let me move this. Okay, so it joins them here. So Roxolana, you see, so this is 0 at lag 0. This is lag 1, lag 2, lag 3. So somewhere in here, this is again difficult to see. Somewhere in the third, this here, 3. And again, I wouldn't say this is lag 3. This is like order 3. So I suspect this is quarter, even though it doesn't specify. Okay, it's an order. So if you say lag with this data, you might be thinking in terms of years. But when you say, what tips it off is order. When you say order, then it's order 3, meaning you are going with the frequency that you are using for the problem. Again, I will check on it, okay, Roxolana, and I'll confirm, because it's in the textbook. I want to see exactly what the textbook is using, okay?
Okay, thank you.
Okay, but I suspect because it's not using lags, it's using order. So my sense is this is quarters. Okay.
All right, sounds good.
Right.
So the reason I asked was because for the previous PACF graph.
Yes, for the previous ACF and PACF, it tells us lag 1, 2, 3. But before lag 1, you see 4 quarters. If you see 4 quarters, and before lag 2, you see 8 quarters. So I think we need to make the graph a little bit more explicit in order to distinguish between year and lag.
Okay.
And year and quarters. Okay, your textbook doesn't do that, but again, I'll figure out a way to do that. But for the homework, don't worry about it because you guys are using months. So the frequency will be more. And you can eyeball and see that the frequency is more than is months, okay?
All right. Wait, I also had another question. Can you show me the plot for the PACF for a second, if you could pull it up? I don't even.
Okay, so let me go back. I can plot it again. That's the PACF that we did earlier on?
Yeah.
Okay, hold on a second. Let me go back. All right, so I'll do the PACF for Y.
Wait, can you do it for DY? I think that was the question I had. Yeah.
Okay, for DY, the difference data. Okay.
So,
this one.
Yeah, so over here, I remember when we were learning about PACFs, you said if the line, like, no, it depends on how many lines break through the confidence interval. So over here, 3 lines broke through.
Yes.
So wouldn't that automatically be an AR3 process?
Well, because we're using quarters here, right? I would say it's an AR12. Because this 3 here, even though it says lag, I suspect that this diagram is confusing annual with quarter.
Okay. Yeah, no, that makes sense.
Just one, yes. And what tips me off is if I go inside the numbers here, this is 1 lag, this is 1 lag, this is 1 lag, this is 1 lag. And so there are 4 within this one, you see?
Yeah, yeah, no, that makes sense.
4. Yes, and then there's another 4. So this, where it breaks through to 2 is really quarter lag 8. And where it breaks through here is quarter lag 12. So this is really, in terms of quarters, I would say this is a lag 12 in terms of quarter model. So I would say XT equals maybe no constant 0 plus coefficient with one lag, and then minus coefficient with 8 lag with XT minus 8, negative coefficient, and then positive coefficient, negative coefficient at XT minus 12. Do you understand?
Yes, I think so.
Okay, so on the equation, if you want to write this equation, I don't want to exit this R because I don't want problem. If you want to write the equation, you say XT on the left-hand side is equal to, let's say there's zero constant here, plus maybe plus something times XT minus 1. That's 1 lag here. Minus coefficient times XT minus 8. Minus coefficient times XT minus 12. That is the equation you use.
Okay, sounds good. Thank you.
Okay, all right. So where was I? Let's see. Okay, so we plotted now, and then, okay, so for the next thing I want to do, I ran into a problem when I wanted to do them. So I have to install Tst Series here, okay? All right, so I'm going to install the time series. Yes, sir. Not yet. What I'm going to do for you is I'm going to upload a Word document that has all these commands. So what you do is you activate your RStudio, just copy, this is exactly what I did. Just copy everything in the Word file and put it in the top left-hand corner, okay? Okay? All right, so that's exactly what you do. That's what I did today. Okay, so I installed the package. It's installing Tst Series because I need the Tst Series for everything I want to do below. I tried it without the Tst Series and I ran into some trouble with some of them. It's still installing. Okay, it's done installing. So it is now in my RStudio. So now I'm going to activate I'm sorry. Now I'm going to activate it by doing library. Okay, so it's available for me now to use. Okay, so Tst Series. All right. So now, guys, I am going to run the Dicky-Fuller and the ADF. What does the Dicky-Fuller do for us? The Dicky-Fuller runs for us the null hypothesis of unit root, yes? Against an alternative hypothesis of stationarity. Does everybody agree? I'm waiting.
Yes.
Okay. So the null hypothesis for what I'm going to run now is the null hypothesis is unit root. In other words, the coefficient of xt minus 1 is 1.0. That's what we are usually interested in. The alternative is that it is not a unit root. In fact, the alternative is that it is stationary. Okay. Now, you guys, you're going to see in a few minutes that if I want to do an AR1 model, is the same thing as ARIMA 100. So for Tst Series package, everything is done using ARIMA, okay? ARIMA. But if what you want to do is just AR, then you specify the I and the MA as 00. The same way for Dicky-Fuller here. If you want to run the Dicky-Fuller and the augmented Dicky-Fuller, the ADF and the DF, if you put this thing k equal to 0, that is only the DF. But if you run it without k, you don't specify k equal to 0, that is the ADF. All right. So this package just calls everything ADF. But if you want to focus on the DF, then you put k equal to 0. Okay. Okay. I can explain this more later, but let's go. So here I run the Dicky-Fuller. Now please look for the result. So the result says Dicky-Fuller. The statistic is negative 1.6253. The lag order is 0, and the p-value is 0.377301. So if the null hypothesis is of unit root, do you accept the null or do you reject? Do you fail to reject the null or do you reject the null according to the p-value? What do you think?
We fail to reject.
We fail to reject. In other words, you accept. Yes.
Yes.
You accept. Don't tell my statistics friends I said that. So what would be your conclusion here?
It's a random walk.
It's a unit root process. That means it's a random walk, correct? Okay? Because you accept. Why do you accept? Because 0.7301 is way above the 0.05. Okay? All right. This explosive one, I'm going to remove it. I was just testing out something. So I will remove it before what happened? Okay, I'll remove it. I think I just erased something, but I'll put everything back. I just erased a line. For the ADF, so let me run the ADF now. And the difference between the DF and the ADF is a very specific reason, because the Dicky-Fuller tends to be a little more restrictive, the Dicky-Fuller test, but the ADF allows you to the ordinary DF is very restrictive in terms of the lag length. I will explain that in simpler language later. But the augmented Dicky-Fuller allows you the flexibility to do more lags. Okay, so that's the difference. So here, again, if we do the ADF, you see 0.2738. What's your null hypothesis here is unit root. Your alternative is stationary. So here, what do you see? What's your conclusion here again? Anybody?
We again fail to reject.
we fail to reject. And if we fail to reject the null, that means we are quote unquote accept the null. That means we are concluding that this is a unit root process. Okay, good. Let me just run through quickly because I'm running out of time. Let's do we already computed this. Okay, so this I already did. Okay, so let me do the ADF for the difference data. All right, I'll do the ADF for the difference data test. Okay, this difference data gave me some problems because it tells me that the p-value is smaller than the printed p-value. So the p-value is so small. Okay, it's so small. So in that sense, in this sense, I'm going to say that it is stationary. Okay, because remember we have differenced it. When you difference a unit root, the way to handle a unit root process is you difference it. And when you difference it, you obtain stationarity. All right. How many times you difference it to get stationarity is represented by the I in ARIMA. So when I equals 1, like here, I have differenced it one time. Remember, we did difference this one time earlier on. And it says the p-value is so small that it will not be printed. It cannot be printed. So here, you figure out that it is so small that you reject the null of unit root. Whenever you've differenced it, you remove all the trend, you remove all that problem. So now it's a stationary. It goes back and forth around 0. That's stationary. Okay. All right. So that's the gist of this. Let me move on. I want to show you something else before the time goes. Okay, so we have run the unit root, and we have seen that according to our result that this GDP has unit root. When we difference it one time, we get it to be stationary. Okay, now the question is, which AR model is best? This is what you do here. Roxolana, I think it was you who was asking me. So now let us estimate different AR models, and let us see which one that, using the AIC, let us see which one appears to be best. So the way to, so this is like running a regression. This is like running an OLS regression on different models. So this is an AR1 model. Even though we say it's ARIMA, but because it's 100, only the autoregressive component 1. And this is AR2, this is AR3. So let me run each one. And guys, just look at the AIC and tell me which one is better. So this is ARIMA 100. So this is an autoregressive. This is a autoregressive with 1 lag, only xt minus 1 on the right-hand side. So look at the AIC here. Look, the AIC is here, 921. So let me run the second one. Let me run AR2 model. Okay, because here it's only 2. What did I just do? I'm so sorry, I messed this up. Okay, so let me run AR2. I run AR2. Huh? What happened? Oh, it produced it. It's 889, right? 889.44. It gave me some error message about the square root of diagonal, some problem in the matrix, but at least it gave us the AR2. So let me run AR3. Okay, so now we have run AR1, AR2, AR3, based only on autoregressive modeling. Would you say this is best represented by AR1, AR2, or AR3?
AR2.
AR2.
AR2 is the smallest one, right? Okay, good. Excellent. Okay, so you can just protect yourself and say based on the AIC, it gives me the minimum AIC. So there's evidence that the AR, based only on autoregressive models, that the AR2 model is best. Now, let me go and run other types, okay? Let's run moving average. Yeah, Roxolana, go ahead.
Why would you only test up to the third one? Why can't you just keep going? Like, how do you know?
Yes, of course, for your homework, you can keep going.
But for how long?
You can go up to 12, up to, you know, you can go up to 12. That's really up to you. Here, I just left it at 3 because of time, okay?
Okay, sounds good, thank you.
So here, let's do moving average. So this is ARIMA 001. So ARIMA, the AR is 0, the I is 0, and the moving average is 1. Let us see if a moving average will do better. Let's see that. Okay, look, the AIC blows up. So the MA1 is not good. So let's do ARMA11. Okay, let's see. So this is 899.1. It's still not as good as the other one, and so on and so forth. Okay, so you can keep playing. So now you can run it on DY. I can run it on DY. You know, this is autoregressive of 1, xt minus 1. This is MA1. This is ARMA11. This is AR1 MA3. So look, you can play with this, and then you can play with several models, and then choose the one that gives you the least AIC. And then you can say, based on AIC, that this is the model that your stock gives you, okay? So I'll clean this up and then post it either later tonight or early tomorrow morning, but I'll try to post it tonight, sometime tonight. I just have to see some students, all right? So I'll try to post this sometime tonight. And okay, I'll remove some of this. There are some things I try to test out that I won't ask you for homework, but everything I'm going to ask you for homework will be based on the comments here. Okay, everybody? Okay?
Yes.
All right. Any questions? So this is what I suggest. Before you run it with your stock, with your own asset, I would suggest you go to Blackboard and you get this macro database, okay? The macro database is on Blackboard, and it's on, I posted it on Tuesday, March 2nd. So in Blackboard, you should see Tuesday, March 2nd, posted on Tuesday, March 2nd. And you can download it. It's called r_practice_new macro. Okay, and then you can practice exactly what I have done here. Do it yourself, line by line. Don't be in a hurry. Yeah, you can mess around, you can get it wrong and do it again, but use only the comments here, okay? And then when I give you the homework, I'm going to ask you to use these comments to work on your own stock.
Wait, Professor, I have a quick question.
Yes.
So I ran for the difference data, and the difference data has a smaller AIC. So do I treat these data sets as separate ones, or do I have to say,
no, they are separate.
So like I don't have to say that, oh, the difference data is better than
well, yeah, yes, you can say the difference data is better because you already difference it. Remember, when you difference it, you remove the trend. Yeah. Right? And so you remove, so these are really two different data sets. The original one is the GDP, and this one is the GDP detrended, okay? But what we're using the difference GDP just to verify that even though the GDP itself is unit root, it's not unit root processes are not stationary. But when you difference it one time, you get stationary. Okay, so that tells me that this, if this is an ARIMA model, this is an ARIMA model of integration 1, because we need to difference only one time to arrive at stationarity. But what we know is that the original series GDP is highly non-stationary. In fact, the non-stationarity is unit root. Okay?
Yeah, sounds good.
All right. Anybody else with question? All right, I'm going to stop now, and I am going to first stop recording.
This meeting is being recorded.
Okay. Those of you that I said see me, and or those of you I already made an appointment to see.
Professor, the recording didn't stop.
The recording didn't stop? Oh, okay. I pressed
The
pause.
recording has stopped.
Okay, thank you. Thank you for alerting me. All right. So those of you that I made an appointment